टाइम नहीं हुआ है सर,
40 हो गया
38 ही हुआ है। कर दीजिए स्टार्ट।
now the topic of chemistry is related to solid state. डायमंड कल जो पढ़ाए थे उसको जस्ट रिपीट करके आगे बढ़ते हैं। डायमंड, it is sp3 hybridized. It has tetrahedral structure. One carbon is joined with other carbon atom. Its molecule looks like a giant molecule. Its density is high. It is a strong substance. Its melting point is high. It is poisonous. Its refractive index is 2.45, that is very high. Due to this value, it has sharp cutting. In diamond, original form of diamond, cutting is clear, like a knife. So, it is due to high refractive index. It is poisonous in nature. These are the main characteristics, chief characteristics of diamond. Good morning, children. Now, the use of diamond in lead cutter, and in ornament. It is very precious. Due to this, a small amount of diamond is added in the middle portion of gold ornaments. And second allotrope of carbon, that is important example of atomic solid. Good morning, children. शिवाज्ञा कुमारी वन स्टूडेंट है जुड़ा हुआ अभी, शिवाज्ञा कुमारी. एनी क्वेश्चन रिगार्डिंग दिस टॉपिक? Now, other example is graphite. It is also important allotrope of carbon, second allotrope of carbon, or important compound in chemistry. Graphite, carbon is sp2 hybridized. That's why it has planar structure. It has planar structure. Several benzene rings are fused together. Several. शिवाज्ञा कुमारी, नो सर, ये क्या हुआ? Any problem regarding this chapter? You can ask me. No problem. Very good. Graphite. It is clear. Graphite is allotrope of carbon, and carbon is P2 hybridized. So it has planar structure. Several benzene rings are fused in it. It has layer lattice structure. One layer slips over other layer. One layer slips over other layer. It has lubricating property. It is soft to touch. It is good conductor. It acts as conductor because it has mobile pi electron. As for example, several benzene rings are fused in it. This is pi electron, and pi electron is responsible for conductivity of graphite. Its melting point is low, its density is low. These are the main characteristics of graphite. What is use of graphite in our daily life? There are many uses of graphite, but some are important. First, it is used in pencil. It is Mukul Dev. Good morning, Mukul. Are you happy today? The use of graphite. First, it is used in pencil. It acts as electrode in battery. It is used in nuclear power plant. In manufacture of atom bomb, the graphite rod is used. So these are three important characteristics of graphite. First, in pencil. Second, in nuclear power plant. And third, as electrode in battery. In what way you will convert graphite into diamond? This is the important question for you. When graphite is heated at 1600 degrees C and high pressure, then diamond is formed. We take graphite and in a special oven we supply 1600 degrees C temperature and pressure should be high. Then this allotropic form of graphite is gradually converted into diamond. This is the important question of this unit. In what way, in what condition you can convert graphite into diamond? This graphite allotrope is heated at 1600 degrees Celsius at high temperature, then we get diamond. Now we will learn about fourth type of crystalline solid. We'll learn about fourth type of crystalline solid. This is molecular solid. This is molecular solid. Actually, this molecular solid is divided into three parts: non-polar molecular solid, polar molecular solid, molecular solid, and third, hydrogen bonded. Third is hydrogen bonded, that is ice. There are three kinds of molecular solid. First is non-polar molecular solid. Basic structural unit, atom or molecule. Example: helium, neon, I2, H2, Cl2. These are the example of non-polar molecular solid. Weak van der Waals force exists in it. Polar molecular solid, HCl, NH3, HF, these are polar molecular solid. And hydrogen bonded, H2O, ice. This is third example of molecular solid. In polar molecular solid, dipole interaction occurs. In polar molecular solid, dipole interaction occurs. In polar molecular solid, dipole interaction occurs. Now we will discuss about the characteristic of molecular solid. Characteristic of molecular solid. First, it is found in liquid or gas. Second, it is soft. Third, melting point, boiling point, low. Fourth, intermolecular force, weak. Intermolecular force, weak. Non-conductor of heat and electricity. Non-conductor. These are the main characteristic of molecular solid. Main characteristic of molecular solid. Now, after finish the types of crystalline solid, we repeat the question related to previous topic. This question is mentioned in your NCERT book. In text question, what is similarity? Similarity and difference between metallic and ionic solid. Similarity and difference between metallic and ionic solid. This question is related to classification of crystalline solid under the heading of ionic solid and metallic solid. Just we repeat this topic, just we repeat the previous concept. Similarity. First point, a strong force of attraction occurs. Yeah, a strong electrostatic force of attraction. A strong electrostatic force of attraction. A strong electrostatic force of attraction occurs in both. Both are conductor. Ionic solid and metallic solid. Third point, melting point of both is high. This is the point of similarity between metallic and ionic solid. Is it clear? Dear student, this point is clear. Bolo. Point of difference. Point of difference. First point. In metallic solid, attraction between kernel and sea of electron. Attraction between kernel and sea of electron. But in ionic solid, attraction between cation and anion. One point is also important. In similarity, both are non-directional. Both are non-directional. This is also important point. Both are non-directional. So, but in ionic solid, attraction between cation and anion takes place. Second point of difference, in ionic solid, conductivity is due to movement of ion. In ionic solid, conductivity is due to movement of ion. Movement of ion in fused state. In fused state. In metallic solid, conductivity is due to electron, movement of electron. ये दोनों पॉइंट तो क्लियर है. Point of difference between metallic and ionic solid. In ionic solid, attraction takes place between kernel and sea of electron. While in ionic solid, attraction takes place between cation or anion, as for example NaCl, Na plus and Cl minus, CaCl2, Ca plus plus and 2Cl minus, Na2O, 2Na plus and O2 minus. It means one metal and one non-metal, one metal or two non-metal, two metal or one non-metal, anyone. And second point, in ionic solid, conductivity is due to movement of ions. In ionic solid, as for example, we take NaCl and it is dipped in a water, then NaCl is converted, breaks down into Na plus and Cl minus. This Na plus and Cl minus is free to move throughout the glass, throughout the system, and this cation and anion is responsible for conductivity of NaCl. तो क्लियर है कि आयनिक सॉलिड में कंडक्टिविटी मूवमेंट ऑफ आयंस, लेकिन इन मेटालिक सॉलिड kernels and sea of electrons are present. The attraction takes place between kernel and electron, and this free electron is fully responsible, totally responsible, completely responsible for conductivity of metallic solid, zinc, silver, iron, aluminum, gold. These are the metals, and this solid is called metallic solid. Are you satisfied? Have you any problem regarding this topic? Anyone? You can ask me. Very good. In NCERT book, one question is mentioned. What is the role of melting point on the stability of solid? What is the role of melting point on stability of solid? Or in other words, common stability of solid is reflected by melting point of solid. The question, role of solid melting point, role of melting point on stability. Stability. किताब में अपना देख लेना प्रॉब्लम इन टेक्स्ट में, हम प्रॉब्लम को शॉर्ट फॉर्म में लिखे हैं. रोल ऑफ मेल्टिंग पॉइंट ऑन स्टेबिलिटी. It is clear melting point is directly proportional to stability. Melting point is directly proportional to stability. Higher the melting point, more will be the stability. Lower the melting point, less will be the stability. This concrete concept is explained by taking the important example. This important example is as example 1, H2O and ETOH. Water and ethanol. A strong hydrogen bond, a strong hydrogen bond, weak hydrogen bond, weak hydrogen bond. So melting point of water is greater than ETOH. Clear? Melting point of water is greater than ethanol. Other example, ET, OET and CH4. Weak van der Waal, weak van der Waal force or London force exists in CH4, non-polar molecule. Or ETOH, dipole-dipole interaction or weak hydrogen bond. Dipole-dipole interaction, dipole interaction exists in this molecule. Dipole-dipole interaction exists in this molecule and weak van der Waal force exists in CH4. Due to this melting point is high, and melting point of this CH4 is weak. Melting point of the CH4 is weak. This is your answer of your question in NCERT book. Isomorphism. Isomorphism. This topic is important but not mentioned in your CBSE NCERT syllabus, NCERT book. But this question is simple and important. Isomorphism. The word iso means same. The word iso means same. Morph means form. Two or more compound. Semi is having similar composition, similar properties is known as isomorphism. Similar composition है, सिमिलर लैटिस स्ट्रक्चर है, सिमिलर प्रॉपर्टीज है, ऐसे कंपाउंड्स के पेयर को हम क्या कहते हैं? आइसोमॉर्फिज्म. सिंपल एग्जांपल Ag2s and Na2s. Similar composition, similar arrangement, similar properties in many respects are found between these two compounds, and this pair of compound is called isomorphism. This compound is called isomorphism. Now we discuss about other topic. Steno law. What is steno law? Steno law is the law of crystallography. Steno law is law of crystallography or first law of crystallography. According to steno, we take 2, 3 or more sample of same substance, or in other words, 2 or more crystal of same substance. Then we will find that the interfacial angle in all the crystal remains same. Interfacial angle in all the crystal remains same. ऐसे समझो कि कोई क्रिस्टल है, एक ही सब्सटेंस का डिफरेंट क्रिस्टल है, उसको डिफरेंट साइज में हम काटते हैं. जैसे गोल्ड है, आयरन है, एल्युमिनियम है, उसका डिफरेंट शेप में हम काटते हैं. इस शेप में काटते हैं, इस शेप में हम काटते हैं, इस शेप में हम काटते हैं, डिफरेंट शेप में हम काटते हैं. लेकिन दिस इंटरफेशियल एंगल is always same. The interfacial angle of different crystal of same substance remains same. This is the concrete concept of steno, and this is called steno law of crystallography. This is called steno law of crystallography. हाँ, देखो हिंदी क्लासेस, which स्कूल, जैसे गोल्ड है, आयरन है, तो मेटालिक सॉलिड है, उसको डिफरेंट फॉर्म में ले लो, लंबा, चौड़ा, मोटा, चिपटा. तो डिफरेंट क्रिस्टल किसी सब्सटेंस का, आयनिक सॉलिड हो, मोलिकुलर हो, कोवैलेंट हो, मेटालिक हो, उसका डिफरेंट क्रिस्टल ले लो, और हर क्रिस्टल का इंटरफेशियल एंगल तुम मेजर कराओगे इंस्ट्रूमेंट से, तो उसको मेजर करने के बाद इंटरफेशियल एंगल दो फेस के बीच के, दो एज के बीच का जो एंगल होगा वह हमेशा क्या होगा, सेम होगा, उसमें कोई डिफरेंस नहीं आएगा. इसी लॉ का नाम है स्टेनो लॉ ऑफ क्रिस्टलोग्राफी. स्टेनो लॉ ऑफ क्रिस्टलोग्राफी. कहीं 90 डिग्री पाओगे, कहीं 120 डिग्री पाओगे, कहीं 79 डिग्री पाओगे, कहीं 42 डिग्री पाओगे. तो डिफरेंट सब्सटेंसेस में डिफरेंट एंगल है, लेकिन एक सब्सटेंस के डिफरेंट क्रिस्टल में हमेशा जो इंटरफेशियल एंगल है वह क्या होगा, वह हमेशा कांस्टेंट होगा, इक्वल होगा, उसमें कोई चेंजिंग नहीं होगा. और इसमें किसी प्रकार के चेंजिंग, तब्दीली नहीं होने के कारण इसका एक नाम पड़ा लॉ, जिसको हम स्टेनो लॉ ऑफ क्रिस्टलोग्राफी कहते हैं. इसको क्या कहते हैं, स्टेनो लॉ ऑफ क्रिस्टलोग्राफी. Lattice point. lattice point or lattice side. In lattice structure, one side or one point is reserved for each atom or molecule. The place on which constituent particles are situated is called lattice site, lattice point. जैसे ट्रेन है, हर आदमी के लिए, हर यात्री के लिए एक सीट रिजर्व रहता है, उस सीट पर वही बैठता है। तो जो लैटिस स्ट्रक्चर आपका है, वह लैटिस स्ट्रक्चर कई एटम मॉलिक्यूल या आयन से बना रहता है। 2 डायमेंशन में, 3 डायमेंशन में, 2 डायमेंशन में या 3 डायमेंशन में अरेंज करते हैं। तो जो स्पेस, जो जगह, स्थान किसी एटम या मॉलिक्यूल के लिए आरक्षित रहता है, या जिसको हम समझते हैं कि यहां 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 आएगा, जिस जगह पर हम उसको सेटअप करेंगे, उस स्पेस को हम लैटिस साइट कहते हैं, लैटिस पॉइंट कहते हैं। उसको हम क्या कहते हैं? लैटिस साइट कहते हैं, लैटिस पॉइंट कहते हैं। उस जगह का नाम क्या है? लैटिस साइट और लैटिस पॉइंट। फॉर एग्जाम्पल, this is your lattice site or lattice point. Now we discuss about unit cell and a space lattice. Unit cell and a space lattice. This is very easy and interesting topic in your unit cell and a space lattice. Unit cell, it is a smallest repeating block. It is a smallest repeating block of crystal. It is a smallest part of crystal. When this smallest part is arranged systematically, regularly in 2D or 3D pattern, then we get a space lattice. It means union of unit cell, unit cell is equal to a space lattice. Union of unit cell is called a space lattice. Unit cell is repeated over and over again, then we get a space lattice. In other words, we can able to say that the unit cell is entire picture of the space lattice. Unit cell is entire picture of a space lattice. स्पेस लैटिस का यूनिट सेल क्या है? इंटायर पिक्चर देता है। अगर यूनिट सेल वीक होगा स्पेस लैटिस वीक होगा, यूनिट सेल स्ट्रॉन्ग होगा, स्पेस लैटिस स्ट्रॉन्ग होगा। जैसे समझो सेब के एप्पल के एक बॉक्स में एक सेब जो है वह यूनिट सेल है, उसको जब सिस्टमेटिकली एंड रेगुलरली अरेंज करके एक डेफिनिट फॉर्म देते हैं तो वह क्या होता है, स्पेस लैटिस। एक वर्ड है चिड़िया है, वह कहीं बैठी हुई है, वह चिड़िया क्या है, यूनिट सेल है। अगर उसी तरह का 100, 200, 1000 चिड़िया इक्वल डिस्टेंस पर बैठी हो, इक्वल साइज का वर्ड इक्वल डिस्टेंस पर बैठी हो, तो वह पूरा जो पिक्चर होगा, इंटायर जो पिक्चर होगा वह स्पेस लैटिस होगा, और वह पर्टिकुलर वर्ड जो होगा वह यूनिट सेल होगा। सपोज करो तुम एक टेबल पर ट्रे ले लो, एक प्लास्टिक का लाल रंग का बल्ब रखो, और वह बल्ब जो है, बॉल जो है वह क्या है, यूनिट सेल है। उसी साइज का, उसी शेप का, उसी कलर का 100, 200 जितना सेट करे, बॉल को सिस्टमेटिकली 2 डायमेंशन में प्यारे बच्चों अरेंज कर दो। क्या करो, अरेंज कर दो। और अरेंज करने के बाद देखोगे कि तुमको एक स्पेस लैटिस मिला, तो वह पूरे ट्रे में, पूरे टेबल पर जो तुम प्राप्त किया सजा हुआ बॉल वह स्पेस लैटिस है, और उसका जो सबसे छोटा यूनिट एक बल्ब है, एक बॉल है, वह तुम्हारा क्या है, यूनिट सेल है। और सिंपल एग्जांपल, तुम अपने मकान, अपने चौक, अपने बाजार के जो नजदीक स्वीट हाउस है वहां चले जाओ। स्वीट हाउस के बाहर तुम सरसरी नजर से देखना, ट्रे में लड्डू सजा रहता है, तो वह एक लड्डू जो है वह यूनिट सेल है, और उसी लड्डू को सिस्टमेटिक लंबाई और चौड़ाई में सजा देते हैं 8-8 का, 12-8 के, तो वह तुमको क्या होता है, स्पेस लैटिस होता है। द यूनियन ऑफ यूनिट सेल इन द लैंग्वेज ऑफ मैथमेटिक्स, यूनियन ऑफ यूनिट सेल इज कॉल्ड स्पेस लैटिस। चलेगा ना? यूनियन ऑफ यूनिट सेल इज कॉल्ड स्पेस लैटिस। इट मीन्स space lattice is father and unit cell is children. Space lattice is building, unit cell is one brick. जैसे ईंटे का पैदावा होता है, जहां ईंटा तैयार किया हो जाता है, एक ईंट जो है, एक ब्रिक, वह क्या है, यूनिट सेल है, और उसी को सजा देते हैं तो एक डिफरेंट फॉर्म में आ जाता है, और दैट इज कॉल्ड स्पेस लैटिस। हो गया? हाँ, ज्ञान स्पेस लैटिस क्या है, ज्ञान यूनिट सेल, ये क्या हुआ, ज्ञान यूनिट सेल, ज्ञान यूनिट सेल,
अंडरस्टैंड, ठीक है, अंडरस्टैंड,
अंडरस्टैंड, ठीक है।